Okay, we're picking up from where we left off. I think I may have changed the point down in here from the last time that we looked at this file. What I want to start doing now is looking at how to copy objects onto these points so that these points aren't necessarily just here to render as particles, but we're going to use them as placeholders for other objects and pieces of geometry that we want to instance all over here. So the first thing I want to make sure we have are point normals. Houdini uses point normals as one of the many ways that we can rotate our objects correctly and choose which direction they're going to face. Before we do this, let's just take a quick look and see what happens when we have no normals. So first thing I'm going to do is create a test object. I'm going to press tab, type type geometry. And we will just call this test object. I'm going to dive inside, delete that out, press tab, and we will type box. I am going to, I'm going to add vertex normals. And we are going to keep it at a 1x1 box. Let's move the center. I'm moving this way 0.5 units so that it sits right on the axis here. And to help us identify our axes, what I'm going to do is I'm going to select the positive z-axis here. I'm just going to press tab in the viewport and start typing the word color. And we'll color this blue. So I'm going to just make red 0, green 0. And make sure that that is a primitive attribute. Then we're going to go to the x positive axis here. Again, I'm going to type the word color. Make sure that's a primitive attribute, and we will make that red. And then for the positive y, we'll select that. I'm going to tab and type color. And then this will be green. And of course, make sure that's a primitive attribute. So this is going to help us identify which is which axis when we start copying this. And of course, I'm going to label this, put a null there, call this out. We can make that invisible. Okay, so going inside our geometry object, I'm going to press tab and type the word copy and place a copy right here. So the first input is the geometry that we are going to copy onto the points, and then the second input are the template points that we will use to copy our geometry onto. So I can just wire this straight into here. And I'm going to press tab and type object merge. And we will just merge our test object. I'm just going to grab out here, right in here. Wire this together. And right now it's pretty big, it's hard to see. So I'm going to add an attribute that controls the scale here. This is a Houdini attribute that is reserved specially for controlling the scale of objects as they're copied or as they're rendered as instances. And that attribute name is called pscale. So if I press tab and type attribute create, I'm just going to put this right here, make sure it's a point attribute. And we want to call this pscale. So right away, everything's going to disappear, and that's because our attribute is set to 0. But let's say I want to set that to 0.1. Now we can see that the scale has changed on these objects. I can go to 0.2, anything that we want, but we'll keep it at this for now. So one thing you can see is because there are no normals on our object, that the z-axis for all of the objects being copied are all pointing basically toward world z, and then we've got y going toward world up. So we're not really using our underlying geometry to influence the direction of the alignment here. Now, if I want to influence that, what I can do is put down a facet SOP. So I'm pressing at tab and starting to type the word facet. I'm going to place that in here, and we will choose post compute normals. Now when you do this, it adds a point attribute called normal, and we can take a look and we can see that. So you have to make sure, by the way, that you have normals before you scatter, because if we do it afterward, nothing happens. It needs the surface connectivity information in order to compute normals. So again, this has to go before we scatter anything. So we can also use this attributes as well. We can make normals face any direction we want. So if I, again, start typing an attribute create, I'm going to make this one a point attribute called n, which is normals. And you can see, again, everything's zeroed out. And of course, we want that to be a vector because it has 3 dimensions. And now here you see I can choose which axis the z points toward. So normal attributes control which direction our z-axis is pointing. And that should be no change. And of course, if you look at this here, and we're talking about our underlying surface, you notice how the z-axis of our copied objects are always pointing outward from the surface, basically pointing in the direction of the normals. Now, one thing to notice is the alignment of the y-axis here. And you can see that it's kind of a little bit all over the place. We can control the axis of which direction the y-axis is pointing in, with an attribute called up. And we have a couple different ways of doing this. We can just make another attribute. And of course, make that a vector. And label our vector up, lowercase. And then we can simply choose an up vector. And it will do its best to align the objects. When you have an object like this that's round with z-axes going in all kinds of different directions, you're not necessarily going to get like a perfect result, but it is helpful to choose an up vector. We can also use some connectivity information from our surface to do that. So here on our facet, right, we're looking at that. I'm going to see if we can visualize this attribute. So one way we can visualize attributes here is by pressing the D key. And let's see, visualizers here. Now we want to press plus so that we can add a new visualizer, and I want this to be a marker, so that shows us a direction. And now I'm just going to label this up. And then of course the attribute I want to be up here. And let's see if there's anything else we need to do. Let's just change the color here to red so that it's a different color than normals. I'm going to hit close. So what I'm going to do now is press tab and type polyframe. And now the normal, we're not going to recompute the normal, but what we can do is look at the tangents and bit tangents, which have to do with looking at the primitives and the edges for how it determines which way up is pointing. And I'm not sure which one we'll want, so we'll try this first. Just call that up. And let me check the marker again, because we're getting values when instead I actually want direction. So let's right click. Oops. Can I edit this? Let's see. I just double clicked there. Yes, I don't want text. I want a vector. There we go. And we'll change the color here to red. And we'll close this. Okay, so this shows us which direction our up vectors are pointing. And let's take a look and see if bit tangent is better. Let's choose make frame orthogonal, and then take a look at some different alignment options here. So it looks like it's perpendicular to our normals and trying its best to align based on our surface geometry. Now let's just go take a look at what that actually does for our copy here. Going to turn off our visualizers. I'm just pressing D again, and we will disable that. And let's take a look at turning our polyframe on and off. So it's up to you in terms of how you want to deal with alignments. This may be helpful, or you may want to just manually create your own attribute, which I deleted down here. You may want to create your own attribute as well. There's a bunch of reasons why you might want to choose one over the other, but we probably won't get into that. Next thing I'm going to do is start looking at a little bit more of scale and start adding these things actually into our multi-scatter asset here. So let's save our file.